Right, so I'm Josh Long. I'm the developer advocate for the open source Spring technologies at Pivotal. How many of you have heard of Pivotal? Just a quick show of hands. It's the new home of Spring. We get handed around, sort of. So we were Spring Source and then VMware, and now we're at Pivotal. We're a small open source startup that launched in April of 2013. Small mom and pop company, 2,500 people or so. We are the home of Redis. How many of you have heard of Redis? Okay, good stuff. How many of you have heard of RabbitMQ? Okay, we have a Hadoop distribution. Anybody heard about Hadoop? All right. What about Cloud Foundry? Cloud Foundry, going once. Okay. Open source platform as a service. It's the bee's knees. Good stuff. What about Greenplum? It's okay if you haven't. That feeling in your tummy, I get it. You know. Gemfire. Anybody hear of Gemfire? Okay. Distributed data grid along the lines of Hazelcast or Coherence. And then of course Spring. And Spring is huge. It's massive. We have a lot of great stuff there. So what we're going to talk about today is building and managing the microservices, the complexity intrinsic in microservices. The important thing to remember, by the way, that's like coordinates and stuff. Email if you have questions. If you leave this room more confused than when you entered, please don't hesitate to reach out to me. I am forever at your service. I am like your RabbitMQ message queue, a little bit asynchronous, but I will get back to you eventually. Okay. You guys want to hear a JavaScript joke? Let me call you back. Oh. Okay, fine. Moving on. But so yeah, Twitter, email. Please don't hesitate. I'm actually writing a book right now for O'Reilly on using Spring Cloud, Spring Boot to build microservices. So this is right up my alley. We talked about Pivotal. So okay, now I want to do the kind of motivational, just a few very short slides to kind of segue into this, and then we'll talk a little bit. We'll do a very, very quick look at something called Spring Boot. How many of you have heard of Spring Boot? You guys remember that from last time? I'm sure you've seen it a few times. It's awesome sauce. So when we talk about microservices, obviously Chris talked about most of this already, so it's sort of redundant. But a lot of us need to embrace this architecture because unlike the capacity planning problems of yesteryear, we have a new opportunity, right? We have the ability now to build something that we built in our bedroom at 2 in the morning, and if it's good enough, it'll get the same kind of traffic as anything that has ever appeared on the Super Bowl, as anything that has ever appeared on Oprah or Slashdot or Dig or Reddit. You understand? There's an opportunity here now to scale out to unimaginable heights, and your application very well may have to contend with that. This is not exclusively the province of the Googles, the Netflixes, the eBays, the Twitters now, right? You will have these problems, and in the world of cloud economics, there's no reason you couldn't be ready for them as well. You know, you should be able to handle that. So mobile, of course, is a huge driver of that. That creates a marketplace for people to develop applications that need this architecture. Social is a huge one. You can take the most awful, terrible things ever, and then base them on this platform, and that platform gives you a reach that you wouldn't have otherwise had. Anybody hear of Instagram? All the kids are using it. It's basically image magic. Well, it's not even that, really. I don't mean to disrespect image magic. It's not quite that. So it's got, what is it, 300 million active users. But it's image magic as a service. And it's because it's got that connection on top of, on Facebook, you know. A lot of different use cases here, a lot of different drivers for scale. So you really could have this problem. You can't afford to ignore them. When we talk about microservices, this is not a new discussion. I point people all the time to this amazing, very, very prophetic thread from Ken Thompson on the mailing list in 1992, the debate between Linus Torvalds and Andrew Tannenbaum, the progenitor of Minix, which is a microkernel-based operating system. The thread is, I think, pretty awesome. It says, this is Ken Thompson, Unix luminary, you know, Unix god, saying, I would generally agree that microkernels are probably the wave of the future. However, it is, in my opinion, easier to implement a monolithic kernel. It is also easier for it to turn into a mess in a hurry as it's modified. Sums it up, doesn't it? Except this is 1992, so long time ago, right? We're actually many years ahead, and he got it right back then. This speaks volumes about sort of the tension between this microservice architecture versus the monolithic architecture. You replace the words microkernel with microservices and monolithic kernel with monolithic applications, and it still holds true. And I think that's pretty impressive. In this case, we know that the monolithic kernel is the one that actually won. Linux won. It wasn't Minix. It wasn't Windows NT. It was Linux rather, right? This big, fat, statically assembled thing. And that's OK. if you're writing a low-level operating system whose sole world is just interrupts and drivers, right? At that point, speed is more important than scale, right? You're not scaling out the code base that much. The Linux kernel is actually a very, very small piece of code. It's all the other stuff, GNOME and Kitty, right? That add all the fat and weight and garbage to Linux. So yeah, I mean, yes, in this case, in this one case, the monolith was the better choice. But for the rest of us, like I just said, we're going to have to contend with these scale problems, and that introduces a lot of complexity. There's also Conway's law. This is actually, I think, a pretty good way to sort of justify why a lot of people are moving to this idea of single, even SOA. This justifies SOA as much as it does microservices. Why do we care about having singly focused, organizationally centric service boundaries? Because then we can evolve the business and the services in tandem, and they're not coupled, right? It's very obvious. The other way of stating this is that if you have 4 different teams working on a compiler, your compiler will invariably have a 4-pass compiler. You see what I'm saying? So that should be part of your architecture, your design. Now, OK, let's look ever so briefly. I'm going to do a very quick review of Spring Boot because I want to lay to rest forever this idea that building a service is hard, right? A lot of people, the naysayers, they say there's complexity involved in standing up microservices and that it adds a lot of moving parts to the system. And what I'm going to do today is we're going to show how easy it is to get a working service and then how easy it is to manage the complexity involved in having these services talk to each other. The first part we're going to handle with Spring Boot. I think Spring Boot is the dragon slayer here. That's the one that subdued the otherwise unruly chore of building something concise in Java, or in this case, Groovy. So how many of you, again, Spring Boot here? How many? OK. There's a few different ways to go. I recommend start.spring.io for all your getting started needs, right? So you go here, you do the normal pro forma stuff, the group ID, the artifact ID, the name, the description, package, blah. Choose Maven or Gradle. Choose Maven POM or Gradle build versus an actual skeletal directory structure, which has basically an empty class and an empty property file and all that. You can choose jar or war. It's 2015, so I'm going to go ahead and choose jar because why? Why would you ever do that other one? Java 1.8, you can choose Java 1.8, but I'm just curious, how many of you are using Java 1.6? It's OK. You're among friends. No judgment here. I love you. How many of you on this? OK. OK. I'm just going to, it's end of life. I'm just putting that out there. Just leaving that there. Oracle hates you, and it's end of life. So I wouldn't leave my code like that. I wouldn't leave it on 1.7. Java 1.6 rather. I wouldn't leave it on 1.7 either because that's about to be end of life. So 1.8 is pretty awesome sauce. I would check it out if you can. Choose Groovy or Java, whatever you like, and then you go over here and you choose the type of workloads that you'd like to support. Whoops. Hello, hello. Go back. So can you see that? Can you see it? Can you see it? Yeah. OK. So you choose the kind of workload you'd like to support with your application. You say, for example, that I want JPA, and I want to build a web app, and I want to have operations integration, for example, that. And then you hit generate, and you get a little zip file, and you can open the project in your IDE, and you're off to the races. That's the Java version. And you'll see it's actually very trivial, but I don't have a lot of time, so I'm going to go ahead and cheat a little bit. We'll just do it with Groovy. How many of you have heard of Groovy? It's pretty darn groovy. So I'm going to go here to my little computer here. I'm going to say touch hello.groovy. Atom, hello. How many of you are using Atom? Anybody? Awkward. What about Sublime? OK. So Atom is kind of like Sublime, except that it takes more memory than most Linux kernels. And because it's based on Chrome and it loads all the things. And as long as you've got a lot of RAM, it's great. So I'm a big fan because it's very big. So I'm going to say at-rest controller. Yeah. Nope, that's not what I meant. At-rest controller, like so. Class, greeting, come on, greeting controller. And I'm going to say def hi, path variable, string, name. OK. And I'm going to say at request mapping, like so. And I'll say hi, name. And that is this maps to this right here. And then I'll return an object and an object literal in line, kind of like JavaScript. Hello, name, and then I'll save it, and I'll go to my command line, and I'll use the Spring Boot CLI, and I can say spring run hello.groovy. And then what that'll do is it'll, well, very importantly, very importantly, it will print out good ASCII artwork. Now this ASCII artwork, I don't know if you follow the trends, but the latest in technology involves ASCII artwork. I've spent a lot of time among the natives, among the Node.js crowds, for example, and their vision, I've discovered, from time immersed in their camps, is based on ASCII artwork. They can't see you if they don't have that to calibrate. So this is how you tame the savage beast. It's how you communicate. It bridges the communities. We did a lot of work to get this right. We have 2 PhDs that work on the Spring Boot team, 2 PhDs, and it tickles me to no end to think that somebody at some point got a ticket or a GitHub issue or a Jira. We don't use Jira for Boot, but I just put that out there so you'd feel better and you could relate. If you can't, that's okay. There was somebody that got an issue that said we need ASCII artwork, damn it, and they delivered. Look at that. It's gorgeous. You could change that ASCII artwork. There's actually a feature to remove it in Spring Boot. And actually you can put, I think it's like banner.txt, and people ask, can I change the ASCII artwork? I mean, I'd love this framework, but can I change the ASCII artwork? You can, but don't. I mean, really, who are you to, come on, look at that. You can't do better than that. So anyway, the service is up and running on port 8080. OK, localhost 8080, voila. And then go to hi, Oakjug. And there we go. Very simple REST bits there, not bad. And that's not hard, right? I mean, obviously, that's pretty simple. I'm going to go ahead and use the Groovy language grab annotation. This is a part of a facility called Grape. And it's a way of resolving and pulling down Maven dependencies. And it's linked in the code. So I can say, go ahead and bring down Spring Boot Starter Actuator. And that'll bring a module that is called Spring Boot Actuator. It's a bunch of facilities that are designed to support operationalized services. Now, when we talk about, nope, hello. When we talk about Agile, a lot of us think, well, I want to be as quick as possible. And of course, a huge part of the Agile methodology and that whole approach is to have shippable code. And if you're shipping code that isn't ready to go into production, you're doing it wrong, by definition. So what we aim to do out of the box is to make it as easy as possible to be production ready by default. Okay, so the actuator serves that use case. It adds a whole bunch of things. It adds a bunch of facilities to the Spring Boot application designed to integrate with operations, including things that you can use to find out how the application is doing, its state, its health, the status of it, and so on. So I'm going to go ahead and hit refresh as many times as my fast little fingers can go. And then I'm going to go to /metrics. And I'll see here, pretty printed in my little browser, an enumeration of the memory, the uptime, how many threads are running, the classes, the HTTP sessions in the Tomcat instance in this case, and how many requests, in this case 18, have been made to the endpoint /hi/path parameter name. Okay, so I've made 18 requests, and I got a status code of 200 on those. I can go to trace if I'd like to dig deeper, and this is actually just a log of every request made into the application, headers and everything. I can go to beans to get an enumeration of all the Java beans that Spring has wired up for you in service of this application, right? Very, very convenient. I can go to health, and this gives me you can peel back some of the properties and actually expose more, but by default, it'll give you information about the connection pool that you're using for a JDBC connection, or if you have MongoDB or Redis or RabbitMQ, it'll also do the right thing and show you information for that as well. I can go to env and get a dump of all the properties in my environment, which is great if you're trying to debug applications. Remember, a 12-factor app is configured externally through configuration variables, property or environment variables. So having this dump is very, 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 very useful for debugging this kind of stuff, right? You can, of course, change a lot of things about this app. So I'm going to go ahead and kill it now. You may be thinking, Groovy's all well and good, but I'm not going to deploy that nonsense to production. It's a script. They won't respect me if it's a script. It has to have a 20-page deploy summary or something. So I'm going to go ahead and make it a jar so your operations people feel more comfortable. So spring jar, foo.jar, and then I'm going to say hello.groovy. And what that's going to do is it's going to give me a jar, java-jar, foo.jar, that I can then run, just as before, with the libraries inside of it. So I can attach that jar, put it in an email. I can add OAuth, protection. I can add SSL. I can add whatever, and put it in an email, and then somebody can java-jar it. Grandma has the ability to run an applet these days, so she can run this. Java minus jar is within everybody's reach. If your operations people don't know how to run this, then fire them. Yep.
Two quick questions. One,
no such thing.
Those of us a little nervous about like all the black magic behind the scenes. Can you briefly describe what the what you did on the website initially? I mean, did it just basically create a Maven project?
I didn't even do the website, so I skipped. I said this is the way to go for Java, and I'll go ahead and we'll visit that in a second. But this is the Groovy-based alternative. This has nothing to do with Spring Cloud. I'm just trying to make sure we're all on the same page with respect to operations and services and all that stuff with Spring Boot. So, yep.
I've never seen a Spring command line.
Right, it's a Spring Boot CLI. You can do GVM, or you can do homebrew, brew, search, Spring Boot, brew install, Spring Boot, one word, and you'll get it, and it's awesome sauce, and it has the ability to run Groovy-based Spring Boot apps. The web service that we're using right here, the initializer, is itself a Spring Boot Groovy CLI app, right? And jars are really fancy because they're really nice because you can just say, hey, Cloud Foundry, hey, Heroku, whatever. Here's your jar, run it, and it knows what to do. So you just CF push or whatever, and that's the natural mechanism for that. So it should be dead simple to get a service up and running. These people who say, well, moving to microservices is all well and good, but I don't want to have to tease apart all my modules and then everything has to become a service and I have to do REST and all that. Don't tell me that. Even I can do this, and if I can do it, my goodness, you guys have way, way more of a shot. So yeah, this is easy. We can do this now. I'm going to go ahead and, I guess I could, you want to see what this looks like if I generate it quickly? OK, I'll do one last thing. How are we doing for time? I'm leery on time. Oh, you guys are going to, OK. We're going to go as fast as I can here. OK. Oh, hi. OK. And there. Voila. Opening this up in an IDE of some sort. The build file that you get is pretty unassuming. You get a parent POM. That's not required. You can use a dependency management section that has an import scope, or you can use a Gradle-based build. But by default, you get something that is level set, and it shows you all the different dependencies. And then I've checked all these little different dependencies here. They correspond to the checkboxes. So remote shell, the actuator, the web stuff, support for JPA. These are all very opinionated ways to get everything you need to get started with that particular style of workload. OK? Yes, sir.
This framework, or can you, for example, use Grails and include actuator in your?
Well, it is funny you should say that. So Grails 3 is going to be based on Spring Boot. So it is basically a bunch of configuration options for Spring Boot. So yes.
Yes, but is Grails 3 out there?
No. Now that's a bridge too far. It's coming. They're working on having that out by end of March, I think. OK, so that'll be there. But yes, that's certainly the hope, right, is to be able to benefit from all this stuff. So here's your standard basic. This is a brand new Spring Boot 1.2 release. Oh, yeah, sorry.
One quick question.
Yes, sir.
Is there any fixed and documented API for writing your own actuators?
Yeah, it's called an endpoint. It's an interface. And so the question is there an API for writing your own actuators? Absolutely. Here we go. And then you can see I've got endpoints for the metrics, for the request mappings, to get the trace logs for the environment, the health, a dump, which gives you a stack trace, the config props endpoint, which tells you all the properties that Spring Boot will respond to at runtime, and so on. Is that kind of OK? OK, sure. So I'm going to code very, very quickly. This is not what I'm here to talk to you guys about, but I do want you guys to have a feel for it. So voila, class, reservation. This is Java, remember. So I have a public static void main, Spring application.run, empty directory, empty application properties, dumb unit test. You don't need it, of course, but you should always unit test. I'm not saying you don't unit test. I'm just saying we didn't add a lot by doing code gen here. This is a 2-minute trick, OK? And it'll never do it again. So, if you need that. So, OK, I'm going to say private string reservation name, all this same one as always, long ID, ID at generated value. These are standard JPA annotations. Obviously, you guys are building real software, so you won't be using this. But it's relatable to a lot of people. Constructor, another constructor, because JPA is an awful thing. Why JPA? Why? OK. Get rid of that. I've got that. Oh, I need a toString. OK. And then I need a bean of type command line runner. And the command line runner is just an object it's an interface that Spring Boot knows to start up. It knows to call it back with the arguments to public static void main, the string array. So it's an interface with one method. It's public void run. And of course, you can use Java 8 lambdas for that. So I can say, and then I can say system. I'm going to actually do some interesting data setup here. I'm going to inject a reference to that to an object called a repository. I'm going to say, reservation repository extends JPA repository. And again, there are similar analogs for Mongo, for Cassandra, Neo4j, Redis, Gemfire, Elasticsearch. I mean, there's different things, but the point is it's a conventional way of creating a Finder, based repositories, that kind of thing. So here's a Finder method, and it says based on this name of the method, create a method that implements this interface, and then in that method, create a query that says select all from reservations where reservation name equals rn. Okay, so it's conventional, very sort of active record-y, very Ruby-ish. And then once I've defined that bean, I can say reservation repository rr. Okay, and then in here I can say dot arrays dot as list Josh dot for each n. You need to split it for that to be any fun. And then I'm going to say rr.save, new reservation. I'm going to say n. So that is just a cute way of creating two records in the database. Anybody unfamiliar with Java 8 lambdas? OK, yeah, good. So run that, and then I go down here and do rr.findAll.forEach, and then I'm going to print out the records that come back from the database. And you might be wondering at this point, what database? What is he blabbering on about? And that, of course, is going to be a embedded H2 database. Okay, and H2 is it's an embedded database like SQLite or HSQL or Derby. So Spring Boot will automatically create that connection for us if we have no other explicit data source defined. I've already added Spring Data REST, so I'm going to go say REST repository. Oh, no, I didn't add that. I'm going to go back here. I'm going to say Spring Boot starter data REST, like so. OK. And I'm going to go back to demo application, REST repository resource. I'm going to run. Assuming I've killed the Groovy one. Yep, that's good. rm hello.groovy. OK. So that is up and running. Now, again, good ASCII artwork, solid appearance, solid approach, good code. There's a unit test for the ASCII artwork. The data itself is here. You can see it being printed out in the console. I've used Spring Data REST, so I can go here. I can say reservations, and I get hypermedia-based representations of all the data. Hypermedia as in HotOS. Hypertext is the engine of application state. The idea is that every REST resource should have within it everything that every client should need to be able to further manipulate or understand that resource. So self-describing API is very good in the microservice world, not required. I've got the data there. I can actually go reservations 1. I can go to reservations 2. I can go to reservations search, and I got the search endpoints there as well. So you get a lot, even in the Java version. It's very concise. The most nauseating part of the code that I just wrote, by far, was JPA, right? All this nonsense, like the private, the getters and the setters and all that. If you're using a real language, it becomes a one-liner to describe that dumb struct, So OK, any questions on that before we plow into Spring Cloud? Because we got to hurry. OK, good. Magic aside. Now, by the way, the magic, peeling back the magic, there's a file called Spring Factories that lives in every Spring Boot app. It's in the meta-inf directory. And when you go to that file, you'll see org Spring Framework boot autoconfigure, enable autoconfiguration equals, and then a bevy of different autoconfiguration classes. These get started up when Spring Boot starts up, and they define beans that are based on conditions. So for example, here's the rabbit autoconfiguration. It says, load this Java configuration class and call each provider method and define a bean, but only do so contingent on these conditions being true. So should this configuration class be evaluated? Not unless this rabbit template type and the channel type are in the class path. Clearly, they're not. This is red. It's bleeding compiler errors. So it's not going to load the configuration for that. And the benefit of that is I can create configuration classes to install security. I can create configuration classes to set up RabbitMQ and Mongo and security and the actuator, all of this stuff without if the types are in the class path, it doesn't do anything. It's inert. And if it is there, then it just works. And you get defaults that you can override, right? Same thing over here. I can say, if somebody has already defined a bean of type AMQP-admin, then go ahead and continue to evaluate this. Then don't bother evaluating this method. But if they haven't, then go ahead and do it, right? So I can say, well, if somebody's defined a data source, then back off. But if they haven't, for example, in the case of my H2 thing, then do the right thing, right? So we makes it a very dynamic environment. OK, now back to the Spring Cloud stuff. This is what I really wanted to talk to you about. This is the good stuff. So a quick note on orchestration versus choreography. There's a great Blicky by Martin Fowler about microservices. In it, he describes smart pipes, smart services and dumb pipes, in contrast to the old SOA-centric way of having very smart pipes, like an ESB, with dumb services. The intelligence these days lives in the services. This is more of a choreography, not orchestration. When you think of an orchestra, you've got somebody there, waving the baton, leading people in the music. And if somebody shoots him in the brain, then the entire orchestra freaks out and starts leaving the room, and they get all upset because the guy's dead and he's bleeding out. It's not good. You don't want your system to be based on such a fragile model. Instead, build services that are smart, that are like ballet dancers. They get on stage, they have a role, they follow that script. But if something goes wrong, if they stumble and fall, they get up, brush themselves off, and continue trudging on, right? There's no single point of failure here, right? They're all smart enough to react to failure in of themselves. So microservices is all about smart services and dumb pipes. It's very important to think about that. When we talk about the complexity with microservices, we think about Netflix. They do, as Chris very poignantly mentioned, they have 600 different microservices. And by the by, Netflix is a heavy user of Spring Boot, big time. I mean, most of their services are now going to be on Spring Boot. They spoke at our keynote. They're all in on this stuff, right? So this is not. We've had a great rapport with them in the last year and a half, and we've been talking to them a long time, and they've been very vocal contributors back to Spring Boot. And we think Spring Boot is a great way to stand up an individual service. So then the question is, OK, now I've got that service up. What does the complexity look like? They have 600 different services up and running. If you amortize, if say you've got 4 nines of availability, it's a couple hours per service, per instance, per node, per data center. 600 of them at that scale. I mean, we're talking about hundreds of thousands of hours a month of downtime. Even if they get 5 nines, it's going to be unbearably bad downtime. So they can't afford to pretend they live in a world where there's going to be no downtime. It's not even an option. They wish, And so they didn't even bother. Instead, they looked for ways to build robust, resilient systems, systems that are resistant to these failures. They don't fall apart just because there's a failure. Okay? And a lot of that stuff is embodied in their Netflix OSS stack. And they've made a lot of that stuff open source, and we're big fans. So Spring Cloud started off initially as a set of Spring Boot auto configurations, just like we have for Rabbit and for other things, for these various Netflix OSS pieces. It's for microservices what Spring Boot is for the individual service, right? It is a way to make and promote robust, resilient systems. So today we're going to look at a kind of a straw man's microservice system. We've got a web application that's going to connect to 2 backend microservices. And then those microservices are going to talk to 3 different pieces that come from Netflix and from us, from Spring Cloud. The config service, the Eureka service, and the Hystrix dashboard service. Okay. Now, worth mentioning that the things on the bottom, you have to get them right once, and then you can operationalize that. You can teach operations that I need this one for my ensemble of microservices. Go ahead and deploy the standard recipe for Eureka, for Hystrix, or whatever. We have at Pivotal a very awesome but super expensive, I mean all the money plus $2, kind of expensive shrink-wrapped version of Cloud Foundry called PCF. Really good stuff. And one of the things that we're planning on doing is you can create a backing service for Hystrix and for all these different things, just as you would like a RabbitMQ or whatever, just like you would on Heroku. But as you're going to see here, it's not all that hard to stand them up without that, right? So first thing you think about when you move to a microservice world is configuration. Maybe not, but it's the first thing we're going to talk about. When we talk about configuration, I'm not talking about configuration in the classical Spring sense of the word. I'm talking about configuration in the sense of I have things that change from one environment to another, and I want to have one golden build I don't want to have to change my build when I move from dev to QA to prod to whatever. And so in that world, it's pretty obvious what to do. I mean, a lot of people use external environment variables to externalize those configuration values. Locators and credentials for backing services, for example, might be externalized. Hosts, ports, that kind of thing. That's a good approach for individual services if you've got maybe 5 or 10, but it gets really tedious really quickly as you start to add more of them. A couple reasons. First of all, you have to restart the service every time you want to make a change to the configuration to make the environment variable visible to the running app, the process. That gets even more painful if you have a lot of instances of that individual service running. So if you have 5 processes, that's not so bad. If you have 500 processes for 5 different services, that sucks. The other problem is there's no accountability. It's not easy to trace those kinds of changes, especially when you get into production. Netflix is a very dynamic environment. They don't have the ability to just let people go into production and tweak things. See what I'm saying? They need to be able to trace what has happened to that service and who did it, and then they need to be able to journal it and go back if something goes wrong. And it turns out that Git is pretty darn good at doing all of that stuff. It's centrally administered. It's journaled. You can roll it back. You can get visibility into who made the changes, when and where. You know. So we built a configuration server that acts as a little bit of indirection between your services and a Git repository. So you can use GitHub. You can use local file system. You can use whatever you want. But the config stuff, the configuration files, be they YAML or properties, live in this Git repository. And then our Spring Cloud-based services will consume that configuration. You know, you'll see it's pretty darn sweet. But you have to stand that up first, is my point. So let's do that. I've got a sample application here. It's the Spring Doge microservice. You can get the code at github.com/joshlong/spring-doge-microservice. It's all there for your consumption. First thing I'm going to stand up is my little Spring Cloud-based config service. And again, this is not my actual app. I don't care about this, but I need this for my services. Remember, this is a creakingly old version of Spring Cloud from November. I wouldn't use this even if I was in the desert and somebody was going to take me out and I had to stand up a microservice. You know, I can understand why you'd be hesitant. There's a brand new version that's much better, faster, nicer, more features, less code. But in the meantime, this still has some cruft from Spring Boot 1.18, which is, again, now almost 3 months old. So you can remove these 2 annotations and reduce it down to 1 today. It's good. And then the API basically becomes @enable config server. Okay, so that's your surface area code. And in every other respect, it's just a regular Spring Boot thing. You're giving Spring Boot a queue. It sees the queue, and it does the right thing. It's going to stand up a service. So I'm going to go ahead and hit run. And you can see I've got a couple of configuration files here. Application.yaml is the same as application.properties. You remember when I did that zip file, I got an application of properties. YAML is just a hierarchical way of describing the same data. I've got your standard stuff here. I've got I'm telling my Spring Boot app to run on this port. And this syntax, by the by, if you see this, means run on the port as provided by the environment variable called port, or default it to this literal string called 8888. Okay? So whenever you see that, it's like a ternary expression or Elvis operator for environment properties. And then for Spring Cloud, I need to tell it what repository to talk to. So I say Spring Cloud config server URI. Talk to this GitHub-based repository. Okay? And I can see that here. And you can see I've got just different YAML files for each service. And you're not going to see me making any changes to application anything throughout the rest of the demo. The only thing that needs an application.yaml is my config server. Everything else is going to know how to talk to this. They will all have a sort of perfunctory bootstrap.yaml, and that's the other config file you'll need. Yeah?
So how will this work for a separate application? Like if I were to build an application, I would have to have a GitHub repository for my configuration files? I'm confused.
Yes.
A little bit. Okay.
Yes. Well, if you want the config server, you don't need it.
A separate GitHub repository for configuration. Okay.
Yeah, for all of it. I mean, if you have 100 services, then you'll put 100 files in one repository. Or you could put, if you have 10 different microservices in one business vertical, and then the other organization has more, whatever. That's up to you, right? The nice thing about this config service is that we add value in flight as well. So not only can we centralize all your configuration for you, so all these different running microservices All they have to know is where the Git repository or where the config server is. And then the config server knows where the Git stuff is based. And then it acts as a proxy. So that's part one. But part two is we can actually do things like you can tell the config server, here's my key. And here's my configuration properties living on GitHub. And for my Oracle production database password, I want you to decrypt it in flight, in memory. So it'll automatically take the password, and as you ask for it, it'll automatically decrypt it for you. So you can actually inject security. Now you've got a journaled way to look at what happened to these config files. It's centralized, and you can change it. And as you'll see in a minute, you can actually change configuration in a microservice live. You can make the changes visible to a running Spring app. So if you have a data source and the data source goes down, and you want to route traffic to another URI or something, you'll see what I'm going to talk about. But that's easy. Okay, so brings a lot of benefits. OK, so this service is up. The only other thing to note is that we have in all of our services a file called bootstrap.yaml. It has, most saliently, spring.application.name. And this is the service ID that you're going to use. You're going to keep this in mind. This is going to be very helpful. Spring.application.name gives you a service ID. And you'll see that used in a lot of different places here. OK, so my application is up and running. It's on port 8888. I go to localhost 88888. And I go to Doge service master, for example. And you can see it's going to give me a JSON structure here that tells me that I'm proxying the config on this file. And the keys and the values in that config file are down here. It's very so much, server.port, and then the Eureka stuff here. We'll talk about that in a second. So here's the Doge service YAML, the actual thing, right? You'll see that for the Spring profile specific configuration below for cloud, we're not seeing that here because I don't have the Spring Cloud profile active when I make that request. So that's the other thing, is it'll only give you the configuration for certain profiles if you want. OK, keep that in mind. We're going to come back to it, but that's up and running. The next thing we need is Eureka. Eureka is a sort of phone book for your services. Again, the API is @enable Eureka server. In Spring Boot 1.2, you can condense these two annotations down to one. You're welcome. So I'm going to go ahead and hit run. Voila. And what this does is it's a service registry. It promotes decoupling of services. If you have, especially in a cloud, right, where services are often fleeting, ephemeral things that spin up and spin down, I cannot afford to rely on fixed locations. I cannot afford to rely on having these services in one place. Having the ability to ask questions about the state of the topology of my cluster is very, very valuable, right? And it promotes, it gives you the ability to handle outages, because you're not going to make a service and then wait for it to fail. You can say, is the service available? Well, if it's not, then I won't even bother, right? So this phone book is something that everybody has to know about, but that's it. Everything else they can discover, right? So you might put this one service behind DNS or put it on a cloud or whatever. So that's going to be on 8761, I think, yeah? Yep, there we are. Hello. Hello, computer. OK, so localhost 8761. And there's our Eureka console. And this is a dashboard that you get from Eureka. And you can see that at the moment, I have no services registered in the phone book. So I cannot go to the phone book via the REST API and ask it, hey, where is the account service? Because it doesn't know, there's nothing registered, right? But this will have that information. This is both a human-friendly dashboard and a REST service. So whatever you need, you'll get it there. So OK, we'll come back to the Eureka bits in a minute, but you have to understand that that is there. The first thing that I'm going to stand up here is my Doge service. How many of you know what Doge is? OK, so Doge is the future of the web. It's why it was created. This is the Doge. Now, I have studied long and hard the power of the Doge, but you may not have yet seen it. So this incredibly cute dog, has warmed its way into all of our hearts and minds over the last several years. I think we can agree that just short of Chuck Norris, this is why the web was created. People take this image and overlay utterances of the form very something, so something, much something, interspersed, salted every now and then with wow. Okay, so wow, very something, so something, and much. Now, I have talked to a lot of customers far and wide. I've talked to Netflix, I've talked to eBay, I talked to Baidu and Alibaba in China. I talked to companies in Japan, and they've all said to me, Josh, They don't say that they need a Doge service, but I could feel it. I could hear it in their voices. They've all thought it. You know, this is something that I could feel coming in the room. So I have built an enterprise-grade Doge service. Now this service is basically a REST API, and I won't bore you with the specifics here, but you can post an image to it and get a Dogified image for your trouble. Okay. So I'm going to go ahead and start it. It has, it's just a Spring Boot app. There's not all that much that's interesting intrinsically, you know. I'm using MongoDB to store the images. I'm using a REST API. It's, you know, standard stuff. So here we go. Of note, I have a Java object called the Doge Photo Manipulator. This is a little library that my friend Phil Webb and I, he's the co-creator of Spring Boot, we wrote that library. And it just does image manipulation. It takes a byte buffer for a photo, and then magic happens. And then you get the Doge photo. Now, this service is up and running now on port 8089. But of course, I didn't really need to tell you that. I could probably just go here and find it. 30 seconds. There's a timeout. Notice that Eureka here is upset with us because we're not running it in high availability mode. It gets really pissy if you don't like do that. So obey. You know. There we go. So Doge service is now there. It's registered automatically, right? It's in Eureka, and I can tell the host and the IP. I can see the status of it. As I add, if I were to start up 10 more Doge services, they'd all get registered eventually. And I'd have a collection that I can enumerate. That happens by virtue of the fact that my Doge service is both. Oh, so first of all, my Doge service is connected to the cloud config service. It's saying, I'm saying to the Spring Cloud, I'm saying, get your configuration from the vcap services environment variable, and then inside that environment variable, there's a JSON structure which has as the first key a config service value. And then inside that JSON structure, there's another key called credentials, and then another one called URI. So I'm walking an environment variable JSON path pretty easily here, right? And then I can say, if that's there, then use that, which is great for Cloud Foundry or some environment like that. Otherwise, default to my local host, which is what I'm using right now, localhost 8888. That's part one. And then in the build, I've got standard boot stuff, Spring Boot, Spring Cloud Starter Eureka. Okay, so Spring Cloud Starter Eureka auto-magically sets up the registration with Eureka based on what's in bootstrap.yaml. Remember that spring.application.name? That's where it got the name of the service. It's identifying itself as Doge service with Eureka, right? The next question, I suspect, is probably where is it going to get the address for Eureka, right? And so that's in the configuration file on the Git repository, basically. It's Eureka client service URL default zone. And then I'm saying here, follow this same kind of thing. I'm saying go to this URL if it's an environment variable is there. Otherwise, just do this. Okay. So that's up and running. The service is very, very, very powerful. This Doge service. I'll demonstrate it for you now since you asked. Doge service. And whoops, I'm going to go back up here. CD misc. Now I've got a few images here that we can use to demonstrate the awesomeness of this service. We'll start small. We'll start with the Doge. There he is in his pristine Doge glory. And I have a script here called Doge-client or underscore client. You don't really need to care about too much of it. I've got a variable here that says HTTP, URI is equal to this. And of course, this is the first parameter into my little script. So it's going to be a key, a correlation key, just a way for me to correlate that this lives on the Doge service some way. And it's an ID I can provide it. It can be an ID, a string, and whatever, right? And then the second thing I need is to provide a file to upload, a photo. And I'm going to use this curl command, which is going to basically do a multi-part file upload, a post, to the endpoint. And then it's going to pass in this file. And then the rest of this is just clumsy JSON and JSON scripting to extract the ID that comes back and then build up a URL so I can print it out. Nothing. Don't ever do this at home, especially if you want to make friends. Don't do that. But this stuff is important, OK? So that's all we're doing. So Doge client, I'm going to say 9, because 9. And then doge.jpg, that's the image. I'm going to hit go. And what I get is I get a result here. I can go to the result in my browser. Hit go. And you can see it says, very Kenny, such microservices, wow. And it's got the blessed Spring Doge icon, so it's certified. Now, this is a start. But I think you guys can agree that this demo is so yesterday, because Kenny isn't even in the room. Who's Kenny? We need new configuration, updated configuration. We have the technology. We can rebuild it. So I'm going to go to my Spring Doge microservice configuration repository. I'm going to go back to the Doge service YAML file. And then let's see. I'm going to modify my Git file. I'm going to say very Chris R so cloudy much I don't know sarcasm. Yes, jet lag. There you go. So hit commit. Now I've updated the change, right? So this Trinity is there, and I'm going to use that. I want to refresh my service. I want to make it aware of the updated configuration. Now, obviously, if I go back to here, my config server. This is the config server, not my Doge service. You can see that it is immediately made aware of what's changed in the config repository. However, if I go back to my command line and resubmit the request, it's not going to work, right? If I go back here again, it still has cached the old values, right? So we can fix that. The way to fix it is to refresh, is to call refresh on the context. We've actually got a special scope that we've introduced called refresh scope. And what this does is it creates a proxy of whatever bean you want, and then in situ it recreates the proxy, the bean inside the proxy. You need to tell it to do that though. It doesn't just do it for no reason, right? So there's a couple of different ways to do it. You can use an actuator endpoint that we've contributed for Spring Cloud called /refresh. You can log in via JMX and use the JMX endpoint there, or you can use Spring Cloud Event Bus, which is based on RabbitMQ, and that will, you just literally add the jar. You say Spring Cloud Starter Event Bus, and every service that's connected to it will be aware of any incoming RabbitMQ messages, and it'll trigger a refresh in the service. So if you make a change in the configuration, send a message via JMS, or sorry, RabbitMQ, AMQP, and then any services connected to that will automatically refresh their state in situ, live. Okay, so I have a little script here. So I'm going to say, it just does this. It says curl -d, curly bracket, localhost 8089 /refresh. This is a curl anise for post, empty form, okay? Refresh. And you can see it dumped out. And by the way, 88, remember, this is my Doge service, right? So it dumped out the key that changed on the config repository. Now if I rerun my Doge client thingy and go to the new URL here, okay, you should see the updated code. I didn't restart the Spring context. I didn't restart the process. I didn't do anything. It's really fast to do that. I did this with an admittedly stupid example, the Doge image client. But imagine a data source. Same thing, right? And you can see what that looks like already. I've got the Doge photo manipulator bean here. And I'm injecting the property value from the environment, which is getting its values from the Spring Cloud config server. Okay, so this could have been a data source URL, or it could have been a host or port or whatever, anything you need, right? So that just works. Any questions on that before I move on? We've got a lot more. Yep.
Yeah. How can you manage thousands of environments, let's say, or like QA, staging, production system?
Set up a different config server for each, and then put the appropriate files in there. Or you can actually specify branches if you wanted to do that. If you wanted to keep it all in the same Git repository, but that's asking for trouble. Is that okay? And then if you need to actually make the changes to thousands of services, RabbitMQ is your man. It'll talk to millions if you want. Is that okay?
How works that for production system? I mean, I will not give maybe access to that kind of branch to developers, or.
Well, so I'm saying you can create separate ones. I would create a Git repository for dev, QA, prod, each one, and then each. They're not. They're going to each, if I'm in production, my production services will talk to a production Git repository and nothing else.
Yeah, but developers introducing new kind of variables, whatever configurations, how will they move?
Whatever your process for letting developers screw around with things in production is today, do that. But make sure that, now instead of going into a running Linux system and tampering with processes that are running, they're just changing things in config files. And maybe keep the big red button that triggers the refresh hidden from them, So, I don't know. Yeah?
What about config information that may have a different access for differentiation, or maybe there's common config between environments? You just ship that in the jar file for the.
Yeah, if you want to keep stuff, I mean, you can still have your application.yamls, or indeed, if you have, forget about environments, but I mean, if you're talking about a bunch of services, like for example, maybe I have something that needs to be in all of them. If you have application.yaml or application.properties in the Git repository, then they'll all read that. And they'll also all read, the config file for their service. Yeah, that's true, yes. But it's a pull request, right? I mean, that is easy. Git does deltas between different repositories, dead simple, you know. Is that okay? Yep.
Where does, excuse me, when you have a service and you want to scale it horizontally, you got to make multiple copies of it, multiple instances, whatever you want to call it. So each one of those instances needs some unique piece of configuration state. How do you manage that? Like, for instance, I cannot put 2 copies of the same port on one machine, right? Delta live. So I have to somehow iterate the port, or I have to maybe deploy it on a different machine. How do you store that so that I can quickly horizontally scale a service?
Well, yeah. Well, there's a couple things. Obviously, the glib answer is use a cloud, and then you don't have to worry about picking a port and making that work. If you want to actually change it at the process level, I can override any property that Spring Cloud sees, or Spring Boot. Actually, this is a Spring Boot mechanism. I can do Java -d server.port equals, and then some value. And that overrides the property there.
Basically, the whole value of microservices and scalability is the scalability piece.
Sure.
So what are your widgets for controlling scale? How do I dimension vertically? Like, give me 5. I need warp speed, Captain. Give me, dimension me wide.
That's a cloud. That's a feature of the cloud. So what? If you're using a cloud like Heroku or, of course, Pivotal's own Cloud Foundry, that's dead simple. You say CF scale 500, and you get 500 new instances of the service, and they all just work. It's seconds, literally seconds, to get it all working. So that's the right answer.
Or like a Docker cluster manager.
Yeah. Like, for example, Cloud Foundry.
Really deals with this kind of port allocation.
So I guess is there any feedback of the running instances that needs to go back to the configurations or a round trip?
If you
storage issue with this.
The Eureka piece is actually, it's a service registry. If you could start your copies, your instances on different ports, they just register themselves.
So they'll register back to the one, the well-known Eureka.
Yeah.
Okay.
And they can all find each other. They can all self-discover from there.
There was like, this sounds like the old Sun RPC port mapper from like the 80s.
Wait, what?
Josh wasn't born then.
No, I didn't hear it. It sounds like something from the 80s.
The Sun RPC port mapper from the 80s.
Okay.
The remote process called port. It was basically a way to deal with the fact that you didn't necessarily know what port a service was going to be up on, so you talk to the port mapper first, which is the service discovery piece, to tell you where to go.
Oh, I likened it to a phone book because that's even more classic. Yeah. I think we all get that metaphor, and if we don't, then.
I mean, it's sort of like if you look at like Docker cluster managers like Kubernetes.
Or Cloud Foundry, the new one, Diego. Seriously.
Yeah. Or
Mesos.
Yeah, Mesos, Marathon, blah blah blah. This is the kinds of problems that they solve, right? And also like Eureka is one approach to doing discovery, but then like Kubernetes or Marathon, they actually have discovery built in as well.
Okay.
So lots of there are ways. I mean, the short answer is there are ways of dealing with this,
right,
which is a little outside the scope of what the application developer does.
Right. So okay, let me get back to this. Is that okay though?
Yeah.
Okay. Food for. Sorry.
So like at Netflix, they have that configuration manager.
RKS.
Exactly. So, are you saying they're abandoning that?
No. There's you can actually use RKS with this. The config server has a bridge, so we can get configuration properties that are set by RKS. But it wasn't a natural integration for Spring environments where you have the environment abstraction. So the Spring Cloud config server is meant to work to prioritize that. It works with RKS, so there is a bridge. You can actually set up RKS if you want. This is more natural though, so use whatever. We use both, in fact. We already support it.
Bridge there just because for historical sakes, in case you have an application that uses that. I mean, for a new application, would you not use that? Is this the preferred way?
I'm not using it at all here.
I know that. Is that what the general production recommendation?
Yeah, I mean, that's fine. If you have some use case that you need the dynamic feature of RKS and that specific approach, that's fine. Again, we support it. It's in the documentation. There's lots of good ways to go. But for a lot of people, this is going to be just fine, I think, as well. So, but we're not saying no. We're just saying we support both. It's much easier than saying no or yes. Depends on your use case. I don't want to drill down too much into all that right now. Is that okay? Can we come back? Okay, because we have so much to go and we're running out of time and I feel bad. So now, next service. Doge is up and running. He's live. We've refreshed his state up and quickly. I'm going to cheat in the name of expediency here. I'm going to kill Doge. Goodbye. And I'm going to restart Eureka. And then I'm going to start the account service. And the account service is, again, a very stupid, it's just a JPA entity with a username and an ID, kind of like that reservation, nothing fancy. I just wanted something that was different from the Doge service, so I stood up this little REST API. I'm using Spring Data REST, so the same thing. It's an interface. Interface down here, and it's got a JPA entity, and it needs to talk to the Doge service. So the idea is that an account might have, oops, Eureka Doge is gone. Gonna run this. Okay. The idea is that an account has information about itself. Remember that HotOS thing I was showing you before, those links? Each resource has information about how to get back to itself. It has a self link, an externally addressable URI. And I can see that here, localhost 9098, like that. Go to /accounts, and you get a bunch of POJOs that have links back to themselves. What I want to do is also to have this service available. I want to be able to get the link to the Doge service if the Doge service is available, right? But if it's not available, then I don't want it to just fall over sideways, right? So again, this is where Eureka can really be invaluable, because that little bit of indirection helps us make this very, very smart. So what I've done is I've got a little bit of glue code. Font is too big. Got a little bit of glue code, and the way I've done this is I've said, OK, Spring Data REST, whenever you render a POJO of type account, it's going to be wrapped in an envelope called resource, which contains the collection of links and then the POJO, the payload. And then I'm going to say this is a resource processor, which is a callback interface for all envelopes of type resource with a payload of type account. So Spring Data REST, whenever it renders an account, is going to call this callback object and give it a chance to contribute new links to be rendered. And I can do dynamic things. I can say, well, if the service is available, add a link. If it's not, then don't. You could do this anywhere, of course, but we're doing it here. So here I'm saying, I'm going to inject the Doge client. I'm going to say Doge client, build the Doge link given the account object. And if the link that comes back is null, then don't add it. If it isn't null, then do add it. I go here, and I've got this little bit of integration glue code in my account service. It's the Doge client, and I've injected the, there's actually now a Spring Cloud Commons discovery client that works for both Console and Eureka. But this is the Netflix-specific one. And I'm saying inject the discovery client, and then use that in this build Doge link method to ask Eureka for the next available service called Doge service, and give me back an instance info, which contains information about that service, the host, the port, etc. And then I, kludgily, ugly build up a URI here, in place. You could have done this a lot of different ways, but this serves the point, right? So now, if I run Doge, I should be able to go over here now and run it again. And you can see it's Eureka, go down. Account service is there right now. And we've just started Doge, and so in about 30 seconds, we'll see that available. The important thing to remember is that this is actually a very low-level way of doing this, right? I'm using the discovery client directly here, and I'm asking it for all the information from Eureka. I could use Ribbon. We have direct support for Ribbon, which is the software load balancer library from Netflix. And it provides a bunch of algorithms for doing load balancing among configured instances in Eureka. We have that plugged into all sorts of pieces, like the REST template, for example. And I can actually say, and I can use the Spring REST template. I can say REST template, blah, whatever for now, and then REST template dot get for entity HTTP Doge-service, like that, foo, bar, whatever. And that's a REST client, but that Doge service is an actual DNS. It's a Eureka service ID. It'll, behind the scenes, give me a blessed REST template that knows to talk to Eureka. It gets the service ID, and then uses Ribbon to do software load balancing. And you can plug in custom algorithms for Ribbon's load balancing, right? So that works very nicely there. And we also support feign. Feign is a way of describing, you describe a REST service in terms of a Java interface literally just an interface with Spring MVC at request mapping annotations on it. And it'll give you a proxy, a client that implements that interface. And it's declarative. And it is also Ribbon and Eureka aware. So again, this is a very low-level way to go. I just want you guys to see that we have it there. Doge service is now up and running. Account service is up and running. If I go back to my thing over here, you can see that the Doge service has been now represented in the links that comes back in the output. Okay? So this is one of those ways where you can prevent system outage from causing trouble, right? Actually, I think Chris here is the one who gave me that amazing example. Was that Fred George? Talks about the human body being kind of a microservice system. Dick Gabriel, yeah, just one of the best analogies ever. If you have, you know, if you are a human body, a microservice system, and you prick yourself in your finger, you shouldn't blue screen, you know, like you should be up and running despite the cut in the finger. So this is that, right? This is graceful degradation in the example, and I think it's awesome. Actually, the search engine example, I think that's another one you gave out, right? Was if the search engine goes down in Netflix, everything else still continues to function.
Yeah, like if you're aggregating a page and the recommendation service is down, you still want to display the page, except you can have no recommendation. The account,
you can modify your account, you can stream. You may not be able to do a search, but it'll be back. And so this is how you build that kind of a system, okay? Now, the other side of the coin is, what if something goes wrong here? What if there's no service available and I haven't done the right thing and I didn't check for a null here? I've got a service-to-service call, and this, despite my best efforts to write the right code, might blow up in my face. I might get an exception. And if this gives me an exception, then I'm going to have I have the risk of a cascade, right? I have a service boundary that's calling another service, and that boundary that's a weak spot, right? Anytime you have a joint in a machine, that's a spot where the thing can break. And I want to limit that cascade. I want to prevent it from cascading out. I want to limit that error and prevent it from cascading out. So I'm using Hystrix, which is from Netflix. It provides, among many other things, the circuit breaker pattern, an implementation of the circuit breaker pattern. It's not particularly hard code to write, but the basic idea is that if this service gets called so many times and it fails, Hystrix will trap it, and it'll call a fallback method, in this case, the default Doge link method, and it'll take the value from that instead. Okay. The benefit of this is that I can keep and isolate failure. The circuit breaker, of course, comes from the idea that if I have a house and there's electricity surging through the circuits, I may lose the lights, but I don't lose the house. There's no fire. You know. Another name for this pattern is the bulkhead. You might have read Michael Nygaard's amazing book, Release It. A bulkhead is designed to isolate in a vessel, in a boat, water that floods the boat, right? So you want to keep it contained in that one section to prevent the whole thing from sinking. So whatever your analogy is, it should be pretty obvious. This will work, but it's nice to be able to get access and to see that. And so for that, I'm going to turn to the Hystrix dashboard. And again, same thing as before. This is actually markedly simpler in the brand new version of Spring Cloud. These three annotations go away, and then it just becomes these two right here. This goes away. And then this goes away. So it becomes public static void main, and it becomes @enable Eureka client and @enable Hystrix dashboard. And I'm going to run that, and that'll start up here. Hello. OK. It's on port 7980. Localhost 7980. There's my Hystrix dashboard, and it's asking me to give it a stream, a Hystrix stream. And the stream is a binary stream that Hystrix circuit breakers emit. So whatever service that you have that uses the circuit breaker will also emit the stream, and you can tell the Hystrix dashboard about that stream. So in our case, the account service is the one that makes the potentially volatile service-to-service call. So that's where I've got the circuit breaker. I'm going to go here. I'm going to say Hystrix. I'm going to say it's a localhost port 9098 /Hystrix.stream. I'm going to hit monitor stream, and I can get a little widget here that shows me this circuit called build Doge link, and I can see the action. So now I'm going to go back over here, and I'm going to stress it. There's no way for me to, with my human hands, trip the circuit, but it's an interesting visual. So you can see as I flood it on the right, I can see a moving average of traffic on the left, and as I let go of the gas, it drains off, right? So it's live, it's interactive. If you have a microservice system with hundreds of these, scattered throughout your code, you want to have an aggregate dashboard, and that's something called Turbine, which we also support, right? But not in this demo. So that's also, it's very easy. We actually support that using RabbitMQ. So again, if you're using RabbitMQ and you use our Spring Cloud Turbine integration, it just works. You get a dashboard that you can point the dashboard to that Turbine-based stream, which is very, very asynchronous and very, very fast. OK, finally, crème de la crème. Talk about the client, right? So we're going to look at a web app here. This is a standard Spring Boot app. Not all that interesting, I'm afraid. It says at configuration, at enable autoconfig, at enable Zool proxy, at enable Eureka client, basic stuff. I've got Spring MVC. I'm saying, hey, Spring MVC, whenever somebody goes to / send them to the template called client.html. In this case, it's just client, but it's going to plug that into a view resolver and get client.html. And then other than that, there's nothing really happening here, right? It's just a bunch of Bower, Node.js ecosystem web stuff, client-side JavaScript, Angular, HTML5, etc., REST. Most of this is here, Bootstrap, same as before, templates, public, blah, blah, blah. What is interesting is that I want this client-side service to talk to the back-end microservices. And this is an example of the Edge gateway, or sorry, Edge service or an API gateway. Netflix does this for all of their different client-side UIs. So they have 600 different microservices. If you can imagine all their different client sides, user interfaces, HTML5 web browser, HTML5-based web page is one, of course, but your Roku, your Amazon, your iOS, your Amazon Fire, your PS4, whatever, they've all got a Netflix client, and they've all got different security concerns, and they've all got different things that they need in order to do the right thing. HTML5 services, for example, can't cross the origin boundary, right? And you don't want to go through to all 600 different microservices and add an origin policy to support that new UI. So what they do is they said, OK, we're going to have a stable set of services in the back end and set up these edge services as the middleman, right? As the API gateway that talks to these back ends. And what they use to do that is something called Zool. Anybody here know Zool from Ghostbusters or Greek mythology? I'll take either one. OK. So Zool is the monster in Ghostbusters. He is the I wish I had my slide. I'm not even using the slide deck because we don't have enough time. Come on, Zool. Oh, isn't he cute? It's adorable. So that's Zool. And it is a lot of things, but for our purposes, it's a great way to aggregate other services at a common host and port, right? So I want to just aggregate my Doge service and aggregate my account service and expose them from a common host and port so that my HTML5 client doesn't have to have a cross-origin problem, It's also a great place to insert security. It's also a great place to insert metering and all this other stuff if you want. And you can write custom components, and that's very well supported. For our purposes, we're just going to settle for default routing. If I have the at-enable Zool proxy annotation by default, and then I set up, that's it. If I have that if I have the Spring Boot, the Spring at-enable Zool proxy annotation on the configuration class, and do nothing else by default, I'll get the service mounted underneath my current host with a root of that service ID in Eureka. So if my service is called account service and Doge service, then my Zool gateway will have, it'll be /account-service /accounts /1, and it'll be gateway /Doge-service / and then some sort of Doge service specific path. And I can post and get and do all that stuff to that gateway API, and it'll proxy everything to the back end, right? I wanted to override some of this stuff, so actually, just to show you that you could, I went to the configuration here, and I went to the web app, and I added custom mapping. So here I'm saying Zool, mount everything at /API under localhost :9900, and then mount the account service. And again, this is a Eureka service ID, right? This corresponds to the service ID that we've seen bandied around all day now. Mount that service under /API /accounts, and then mount the Doge service under /API /Doge. So everything I've done before still works, but now I've got it nested underneath the API, and I've got a different string and all that. Okay? Yeah. Yeah. You can. All I want to do is have them exposed under one common host and port. But you can absolutely do combinations of things. You might use RxJava or whatever to.
I think that happens somewhere else in the Netflix architecture, if I remember correctly. Zool is the front-endy thing that does routing, but then any of the composition, I think, happens elsewhere.
Well, yeah, they have actual code that has.
And Zool supports components that you can do that with. Yeah. Okay. Sorry. Questions? Anybody? Sorry? So that's a question of your. There's a couple ways to do it. Obviously, if you're pragmatic and you're worried about the HTML5 form element, that's the only case where I can think of that requires this pragmatic approach. If you're worried about that, then you use versions and the URLs. But the correct Rastafarian approved way is to use MIME types and then have a qualifier in the content type. If you look at, right, so that's the right way to go. But the reason that isn't pragmatic for HTML forms is because there's no way to put in the form a content type. So your service isn't going to know which one to go with in that case. But that's not specific to cloud or microservices. That's just REST. Is that OK? OK. So this is now what I've got done here. Is web app up? I think it is. It should be, what did we say it was going to be? 9900. So I'm going to go to localhost 9900. And I've got my fabulous little HTML5 thingy here. Developer tools. OK, refresh. And if I go to the developer tools here, I can see that it's API, /API. And I get, localhost API /accounts. And then the response is a link that points. It's actually betraying the fact that it's being proxied. That's on purpose in this case. It's a link that points to the original Doge service, not the transformed proxied URL, right? Similarly, if I drag and drool something onto my little upload form thingy here, it's going to post to the Doge service, and you'll see that reflect the original Doge service in action. So I'm going to go ahead and, oh boy, here's the big finish. I'm going to crowd surf if this works. So just be ready. Oh, so money. Every demo is better with the HOF. It's a proven fact. It's science. You cannot argue with this. I have tried it on 1 million people, and they've all screamed enjoy. So this is the HOF.
Can you remove my name?
You're not worthy. You're not worthy. You're not worthy. Now, this is so much better. The web was built for that, really. So that's the uploaded, but notice that the URL I'm looking at here is actually the Doge service specific URL, right? I can get it from my 9900. I can go to 9900 /API /Doges /Doge. Is that right? Or Doge service? What did I say? I think I did something wrong here. There you go. So I can get it mounted through the proxy as well. I just wanted to show you that it works both ways. So that's the client-side story. Now we've looked at ever so briefly. We've looked at Hystrix. We've looked at Zool. We looked at the config server. We looked at Ribbon, or talked about it at least. We could have talked about Feign. We talked about Feign, but we didn't actually see it. We looked at Zool as well for the edge services, and their practice is for every new UI to stand up a Zool-based edge service, right? What I haven't shown you is actually just as long a list, and that's kind of the problem. We have single sign-on support, right? So you can actually set up as yet another service. You can actually set up an authorization server, an OAuth-based authorization server. It amounts to basically 2 objects that are Lambda-friendly in Java 8. I mean, there really are just one-liners. One object to tell the authorization server about your user details, and another one to tell about client details. These are OAuth concepts. I would love to do another talk entirely on that one. But once you've set up that authorization server, and then said @enable Spring Security authorization server with Spring Cloud, it'll automatically stand up that authorization server. And then for all your REST APIs, you say @enable SSO resource. And you have a config property that tells it to talk to that OAuth authorization server. The benefit of that is that all my microservices will look for an access token in the requests. And they're going to validate that access token against the authorization server. And if it works, they'll let the request through. If it doesn't work, then they'll reject it. So I can get single sign-on. I can get security across all 10 different services in a consistent way. I mentioned the authorization server because it's easy to set up, and you might want to integrate with your own backend system's notion of a user and a password. But just as easily, you could have pointed it to Facebook's OAuth APIs and their access token endpoints, or to GitHub, or to LinkedIn, or to whatever, right? So you don't even need that bit. You can still use our client-side story. Just add the annotation and the config property, and that's something you might put in application.yaml, by the way, available to all the microservices, not just one. We also have support for node leadership election and things like that. That kind of coordination through Zookeeper. That's also a Spring Cloud facility. We also have a whole project called Spring Cloud AWS, which provides Spring framework appropriate bindings for things like SQS, for things like Elasticache, for a lot of different things that you might want to use. There's actually an SQS messaging template, for example, that's available. So again, a lot of pieces. I haven't even showed you console. I mean, there's just a lot here. That's a whole workshop, and believe me, I've done those as well. So that I think is it. I think we're kind of at the point where I should crowd surf. Normally, I mention to people that microservices does not imply REST. You can use whatever protocol you want, of course. We don't care. Spring Integration does a great job of standing up services like that. I mentioned the auth bits. I do like that Chris Richardson's microservices.io website. I don't tell him I like it, though. And then I think that's about it. That's it, guys. If you have questions, now's the time. I'll drink some water. Or it's on slideshare.net/Josh Long, and you'll find the whole deck there, all those pretty pictures and everything. Sure. Yep.
Is your GitHub repo that you're looking at today, is that the best way to see all these components working together, or is there something?
Yeah, that's the one I created that. There's actually, if you go to github.com/spring-cloud-sample, or samples maybe, there's a freaking enormous sample application that is being maintained by the Spring Cloud team as they develop. It's kind of like a harness. But because it is as much a playpen for them to test stuff out as it is for you to learn stuff, I don't recommend it. I created this. It's much simpler. It's stripped down. I don't show every permutation of every feature. And actually, I'm going to move it to Spring Cloud, the latest and greatest bits, very soon, the next stable release. And I will do that. I actually even have a branch that's most of the way there, but I don't want to depend on snapshots. So this is like RC3 or something. So it's fixed-ish. Is that OK? Other questions? There must be some. I mean, I know we covered a lot. Yeah.
So like if you have all these different services and you're trying to do ops on the system and monitor all the services, how would they hook into like Nagios or Datadog, or all the metrics you're exposing, like how would you be able to see all your services at one time?
So Spring Boot Actuator is the bit that controls all that information, the metrics and all that stuff. And that has, besides what I showed you for REST, there's actually support for JMX and for the CrashD remote shell. And then we also support the CodaHail. It's formerly called the CodaHail metrics library, but it's now called the Drop Wizard metrics library. Whatever that is, you get that jar added to the class path, and then you can talk to anything that can talk to, including things like Graphite and Ganglia and whatever. So you have just an unlimited amount of options there. I can't give you a specific answer, but believe me, it's a path that we already thought about. Yeah. Is that OK? OK. Drop Wizard metrics. It's Spring Boot Actuator, which is the one that exposes all this information. And then we have an adapter for the Drop Wizard library, which speaks to a bunch of other stuff that we don't directly support, but why not, right? We support 3 or 4 other options out of the box that are pretty useful. And then if you want more, those are there. And actually, I have the original Spring Boot demo. The Spring Doge app is just a single service. This is the microservice version, but there's a single service version of it that actually shows the code for connecting the Drop Wizard metrics library and the actuator stuff to Graphite. So it's actually, if you want to connect it to the Graphite time series graphing thingy, that's there.
Yeah, I use the CodaHail to CloudWatch integration as well.
Great stuff.
So it's been handy.
Other questions, my friend? Yep.
How easy is it to say the inter-process or inter-service communication using like Thrift or Protobuf for that you can serialize it, but it's very compact.
Right. So the question is, how easy is it to make a service call with a more compact, less porous, less fat protocol than HTTP. Spring Framework 4.1, I'm very happy to tell you, supports protocol buffers out of the box, and I think Thrift. I started a project. If you go to my GitHub, github.com/Josh Long, you'll see a project called Spring Advanced Marshallers and Exporters or Service Exporters. Something. It's very long-winded. You'll know it when you see it. It's like a page. And it has marshallers for Message Pack, Thrift, Avro, Zippy, or sorry, Snappy from Google. I'm missing something else. There's like 5 or 6 different very, very compact ones. And it is 2 different things. It is a bunch of, it's an implementation of the HTTP message converter contract so that you can teach Spring MVC and REST about these protocols. And it's an implementation of the Spring Service Exporter bits. So do you remember back in 2003, before people got wise to REST, we had the idea of a service exporter. You can export a bean through RMI or Hessian or Burlap or HTTP Invoker. Well, thanks to, if you use my GitHub repository, you can now export that bean through Message Pack or Avro or whatever. Or you can use the message converter and plug it into the REST machinery from Spring MVC. So either way, you get what you're looking for. I'm not sure what your specific question is, but.
No, my question was like, it's good we have, if we have REST endpoints, but it may not be good like if you are breaking it up into like very smaller devices, very smaller services and aggregate into, like you said, that 100 to 150, that's true because I was there. So there what typically happens, you send a request and it goes to the backend that actually spawns into multiple processors or goes into multiple services, and it comes back asynchronously and you aggregate it.
Sure.
So there we were using, this extremely compact.
Sure. So the REST template in this case, we support both the client side and the server side to consume and produce protocol buffers and Avro and Thrift and all that. If you want more than the ones that are in Spring Framework 4.1, check out my old repository from 2011. For the scatter gather part specifically, Netflix uses RxJava for that. You can use that. That's just fine. Or you can use Reactor, which is it's both RxJava and Project Reactor from Pivotal and Vertex from Red Hat and Akka from TypeSafe, all converged on this standard called the Reactive Streams API. So if you know one, you can use the other one. Doesn't matter. Same trick. Anybody? Okay. Well, thank you very much, everybody. Thanks for coming. Cheers, and thanks for the pizza.